So let us start building an application, right? So here I have invoked an XSA file that we have exported in an same directory where we have our Vivado project, and I've also created an application project and utilizing an hello world template, right? So the first step is to find out the driver which are recommended for our UART PS, right? So we'll just be going ahead in a Baud support package, okay, and here you have PS UART, okay, one, and for that the recommended driver is UART PS, okay. So that is what we're gonna include in our main code, right? So hash include UART PS, okay, and you just need to add a prefix as x dot h, right? So this is the driver for our UART. We also required one more driver that consists of all the hardware related information, okay, and that is xparameter.h file, right? So first we'll just be proceeding to UARTPS and understanding the content of it, right? So if you go through a driver, right, so here you have a different option that you could set for your UART, right? Then you also have a different mode of an operation, right? So you could either operate in a normal mode, the local loopback mode, eco mode, and remote loopback mode, right? So we'll be demonstrating normal mode and the local loopback mode in this specific example. You could explore the other modes such as eco and the remote loopback mode, right? Then if you analyze, so we have again the same structure which we are finding in other driver also, right? So you have UART PS, which is an instance structure, and you also have a config structure, right? So both the structures are present over here, okay. And then if you go through a function, okay, you have a function to enable the transmitter and receiver of UART, to disable transmitter and receiver of UART, okay. The transmitter and receiver of a UART do consist of local FIFOs, right? So we do have a function to verify whether the FIFO are empty or not, right? And other than that, you'll be finding we have a lookup config, CFG initialize, the lower level function to send the data, okay, byte by byte. You also have a function to receive the data byte by byte. Then you have a function to change the baud rate, okay. To set the different mode of operation, you have a set option. So to know an existing option, okay, that we configured for a UART, we also have a get option, okay. We have a function to set the FIFO threshold, okay, and then we have a pooled mode function which allows us to verify whether the UART complete the data transmission or not, right? Then we also have a function to set up the receive timeout, okay, and the interrupt related function, right? So we do have a good amount of function available in a UART PS driver, okay. Let us first proceed with initialization of our UART, right? So we required a config structure first. We go ahead to our main code. We declared a config structure, and this should be a pointer, right? So UART config, okay. Along with this, we also required an instance structure, right? So we'll just be copying this and let it just name this as an UART, right? So once this is done, we declared an independent function which we named as an UART in it, and this will perform an initialization of an UART, right? So first thing is to generate the config structure, right? So to generate a config structure, we have a lookup config where we need to provide the device ID, right? So UART config, okay, and this will be equals to lookup config, and here we need to add a device ID. So where you find the device ID is, you just need to go to an xparameter.h, and then you need to search for UARTPS, right? So this will take us to the location where we have all the data related to an instance of an UARTPS. So this is a device ID that we need to add over here, okay. And as soon as you feed a device ID to the lookup config function, this will generate the config structure, right? So once we have a config structure, we'll just be utilizing CFG initialize to initialize our peripheral. Now this returns S32, right? So we'll just declare S32. Let us just name this as status, okay. And here we require to pass three arguments. First argument is an instance structure, then we need to pass the config structure, and the last argument is the base address, right? So which could also be invoked from our config structure itself, right? So these are the three arguments that you need to pass to CFG initialize, and once you pass this will automatically perform an initialization of a peripheral, and this will also return the status of an initialization, right? Our agenda will be to verify whether status is XST success. Okay, if that is the case, we can see our initialization is successful, right? So if status is XST success, in that case, we could just add zil printf, okay, and mention UART init, okay, successful, right? This makes sense. Else we can see zil printf, okay, and then here we will mention UART init field, right? This completes the process of initialization. Now you could actually perform a self-test also, so that will verify whether hardware is properly configured or not, right? Once this is done, now we go ahead and copy the UART init function, okay, and then we will be adding it over here, right? Now we proceed and let us just remove this string, right? So first let us just work around with changing the baud rate, okay, and analyzing whether we able to send the data at a different baud rate, right? So by default we know that UART is configured to work at 115200, right? So this we already know. If you just customize a block or double click on a Zinc processing system in a PSPL configuration, okay, in a general tab you get an access to UART1 baud rate, which is 115200, right? So this is the default baud rate which is set by a board preset. Now let us try to modify the baud rate, right? So if you go to an UART PS, so here you have an option to set the baud rate, right? So if you click on an F3, so this will basically give a description of this function. So this set the baud rate for a device, check the input for a validity, and also verifies that the requested rate can be configured within the maximum error range specified by the max baud error rate, right? If the provided rate is not possible, then the current setting is unchanged. So this is something interesting. If you specify the baud rate which is beyond the max baud rate that UART PS can configure, it will be simply keeping an existing baud rate. It won't be changing it, right? And this returns the success if everything is configured successfully, else it returns the XST UART baud error, right? So we'll go ahead and copy this. Now this requires two arguments. First one is an instance structure, and then we have a baud rate, right? So we'll just be copying this, and then we go back to our main code, right? So here we add this function, and then first argument is the instance structure, which is UART in this case. Now let us first try to add the baud rate as 9600, which is lower as compared to the baud rate which is set by default, that is 115200, right? And we'll just be verifying whether we still able to get the same data, right? So let us just go ahead and add zil printf, okay. Here we are not utilizing the lower level function which are send and receive that are present in a driver. First we'll just be predominantly working on a baud rate. So once we understand a configuration of the baud rate, we'll be slowly progressing towards a lower level API, right? So let it just mention baud rate 9600, right? So this is the string that we plan to send, right? Now we'll just be building up our project first, right? So once our build is successful, right, we select our application project, debug as launch on hardware. Now this will automatically program our FPGA. First thing that we're going to do is to configure a YT serial terminal to an incorrect baud rate, right? So we know that we have changed our baud rate from 115200 to 9600. Let us first go ahead and select 115200, which is the default baud rate that we've been choosing from the beginning, and select COM4, right? So once we click OK and click on resume button, now you could clearly see we wouldn't able to understand the data, right? This is because we have a differences in a baud rate, right? Now we'll just be disconnecting our YT serial terminal, and then again click on the resume button, again click on this plus button, okay, and now choose the baud rate to be 9600, right? Now you could see we have connected to a COM4 at 9600. We'll just be clearing our console and then relaunching our application. So this is our debugger session. Right click and then you have a relaunch option, right? So once we relaunch our session, now we know that our serial terminal is operating at 9600 baud rate. Now just click on the resume button, right? And you could clearly see that we now get a valid data, right? So this is how we can vary dynamically the baud rate as per our requirement, right? So this is the first setting. Now since we plan to keep our baud rate constraint for this specific example, we could just add this baud rate API, okay, in the UART init function itself, right? So let us just add it. So after we perform an initialization, we configure our UART to operate at 9600 baud, right? Once this is done, now let us just again build our application project. And once build is finished, we'll again be relaunching our application, right? So let's just go ahead and try to relaunch our application again. And now we go to our IT's terminal and click OK, right? Now you could see UART init is successful, as well as baud rate, which is 9600 that is set by user, is also displayed, right? So both of this thing is working as expected. Now we proceed to work on the lower level APIs, right? So how we work with an send and receive function that we have in an UART PS, right?